We're still continuing to look at solving linear systems. Who remembers what a linear system is? Two or more linear equations. What does it mean if you're solving it? What are you finding? We are looking to find the point, write this down please, of intersection, which is a coordinate, right? You're looking for a coordinate that is found on both of the equations. So you're always going to be given two equations and you're trying to figure out at what point do they have the exact same coordinate. But sometimes it's not always possible to determine an exact solution when graphing. So today we're going to be using a new method that's called substitution. It will always give you the exact solution, the exact point of intersection, okay? So this method of solving by substitution involves substituting, this is the key word here, one equation into the other equation. That's basically what we're doing. We're going to do the first example, and we have two linear equations. I'm going to call this equation 1, and this is equation 2. Do you guys see those two equations on your page? So we have to isolate either x or y in one of the equations. It doesn't matter which variable you isolate, but you would look at the equation and figure out, okay, which variable is easy to isolate in either of the equations. If the variable doesn't have a coefficient in front of it, it's easy to isolate, right? So would you pick equation 1 or equation 2? Right, which variable would you isolate from equation 1? That would be really easy to isolate, right? Okay, so we're going to make this say x equals. So we're going to get rid of this negative 2y. What does it become when I move it to the other side? Positive 2y. And 7 is already on the right side of the equation. It's a positive, so it stays as 7. All we're doing is isolating a variable. That's step 1. So pick one of the variables to isolate. So what we're saying now is that x is equal to this. What do you think we're going to do with that? Remember, this is called substitution method. We've isolated x, and we've created an expression of what x is equal to. What do you think we're going to do with that? So we're going to substitute, or replace is another word, the expression. So this is the expression we came up with. We've isolated that. We're going to put it into the other equation. So in the second equation, I have an x. So instead of writing 2 times x, I'm going to take this and I'm going to substitute it. Does that make sense? So wherever you see the x, we're going to, instead of writing x, I'm going to write what? 2y plus 7. So I've just replaced my x, and then I'm going to write the rest of the equation. So we're done step 2. What's next? Yeah? Now, your equation only has a y variable in it. Before it had an x and a y. If you have two unknown variables, you can't solve it. But now we only have one unknown variable because we replaced the x. So now that we have one variable, which is the y, can I solve this now? Yeah, we can solve it for which variable? We're going to solve it for y. So the third step is we're going to multiply, simplify, and isolate. We're trying to figure out what y is equal to. Now that we've replaced the x, so we're going to do what you said. 2 times 2y is 4y. Then I take 2 times 7. Positive 7 is positive 14. Take away 3y equals 13. We have a 4y and a negative 3y that are on the same side of the equation, so they stay the same. 4y and 3y. Those don't move, right? But then I have a plus 14. What does that become? Negative 14. I have a 13 here that stays there. So the only thing I've done is I've moved the negative 14 over. I've gotten rid of the 14. What's 4y take away 3y? 1y or just y? What's 13 take away 14? Negative 1. So y is equal to negative 1. We've just solved the equation for the unknown variable. The whole point of this was to solve this linear system. What we found now is that y is equal to negative 1 for both of the equations. The solution, the x and y, the point of intersection, is our coordinate x and y for both of the equations, right? It's a point of intersection, which means that both equations have that coordinate. If you were to graph it, they both pass through that point. So we just found y, but I haven't solved it. What do I need to find? We have to find x and y. Well, now that you know what y is equal to, what are you going to do with that? Plug it into, does it matter which equation you plug it into? That's the value of y for both equations. So we're going to substitute the value of the variable you solve for into one of the original equations. So this was my first original equation, and this was my second original equation. Which one do you want to plug it into? The first one? Okay, well, we're trying to find x. So you could actually plug it in to this equation. You've already rearranged the original equation. Why not just plug it into that? Because it's already rearranged for you, right? So x is equal to 2 times, what's y? So instead of writing y, I'm going to write negative 1. So times negative 1 plus 7. So x is equal to, what's 2 times negative 1? Negative 2 plus 7. So what is x equal to? What's negative 2 plus 7? Positive 5. So I've just found my x, and I already found my y. So we've plugged it in, and we've solved for the other variable. So what's the answer? What's the solution? What's the point of intersection? Is equal to what? What's the coordinate? 5, negative 1. Make sure you write it in the correct order, x, y. But we're going to do the last step. We're going to check to see if that coordinate, x and y, works for both of the equations. We're going to plug it in to both of the original equations to make sure that the left side and the right side are balanced. So you can always check your answer. If you find the x and the y and you plug it in and it doesn't balance the equation, then you did something wrong. Okay, so we said the solution to this linear system, it has a point of intersection of 5, negative 1. So x and y, x is equal to 5 and y is equal to negative 1. We're going to check our answer. So we're going to take the two original equations. So the first equation was x minus 2y equals 7, and the second equation was 2x minus 3y equals 13. And we're going to plug in x and y for both of them. And we're going to see if the left side equals the right side. Do those values make the equations balanced? Is it true that that's a coordinate on both of the lines? So let's check. So the first one is, instead of writing x, I'm going to write 5 minus 2 times, what's y? Negative 1 equals 7. And then the second one is 2 times 5 minus 3 times negative 1 equals 13. We're going to see if this is actually true. So simplify. You have to follow BEDMAS. Negative 2 times negative 1. You have to do that first. Multiplication. It's positive 2. What's 5 plus 2?
7.
So is this true? 7 equals 7. Left side is equal to the right side? Then you know that this is a solution to the first one. It worked. Let's do the second one. 2 times 5.
10.
Negative 3 times negative 1 is positive 3. What's 10 plus 3? Is it true? Is the left side equal to the right side? Is it balanced? Then you're done. You found the solution. This works for both of the equations.